Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. Let's continue the video for the topic electrolysis. These are the learning outcomes for this video lesson. Predict the identity of the products at each electrode for the electrolysis of a binary compound in the molten state. Predict the identity of the products at each electrode for the electrolysis of a halide compound in dilute or concentrated aqueous solution. Construct ionic half equations for reactions at the anode to show oxidation and at the cathode to show reduction. State that metal objects are electroplated to improve their appearance and resistance to corrosion. Describe how metals are electroplated. Zinc iodide. For molten zinc iodide, you know the products, that is molten zinc will be produced at cathode. So at cathode, you will get molten zinc, silvery white liquid, and purple fumes of iodine gas produced at anode. Iodine gas, and the appearance will be purple fumes. So these are of I2, iodine, and this is zinc. Remember this point that at cathode, there will be a reduction or gain of electrons, which means zinc ions will gain electrons, while at anode, there will be oxidation or loss of electrons, which means iodide ions loses 2 electrons to release iodine gas or fumes. We have reduction at cathode, oxidation at anode. Dilute sodium chloride. Now, in case of dilute sodium chloride solution, we will get hydrogen gas at cathode. This is hydrogen gas. These are the bubbles of hydrogen gas. Because of higher concentration of hydrogen ions in solution, and at anode, we will get oxygen, again due to higher concentration of hydroxide ions. These are O2, bubbles of O2 gas. So write cathode, hydrogen gas. We have bubbles of colorless and explosive gas. Anode, oxygen gas, bubbles of colorless gas. Concentrated sodium chloride. In case of concentrated sodium chloride, we will again get hydrogen gas at cathode instead of sodium metal. This is because although the concentration of sodium ions are high, but you know sodium is more reactive or above hydrogen. So at cathode, we will write hydrogen gas because Na plus above H positive in the activity series. You can even quote the selective discharge in your answer, like you can write sodium ions have high difficulty of discharge or low ease of discharge, again in comparison with H positive or hydrogen ions. Reverse arguments for hydrogen ions are acceptable here. Chlorine gas will be discharged as yellow-green gas. This is because of higher concentration of chloride ions as compared to hydroxide ions in the solution. So at anode, chlorine gas because of higher concentration of Cl negative ions. Zinc iodide. Now I am going to explain how to construct ionic half equations for reactions at both electrodes. This one is for molten zinc iodide. You know the formula zinc iodide ZnI2. At cathode, zinc ions will gain 2 electrons like this. Zn plus 2 molten plus 2 electrons Zn molten. So this is Zn molten. You have to write L for the molten ions. At anode, there will be loss of 2 electrons by iodide ions to release purple fumes of iodine molecule like this. I minus, 2I minus, molten, I2 gas plus 2 electrons. So these are I2, purple fumes of I2. Dilute sodium chloride. This one is for aqueous solution. And here we are having dilute solution of sodium chloride. Sodium chloride. You know that due to higher concentration of H positive ions, it will be discharged as hydrogen gas. Therefore, the cathode reaction was gain of 2 electrons by the hydrogen ions. Cathode 2H positive aqueous plus 2 electrons H2 gas. So these are bubbles of H2 gas. At anode, there will be loss of electrons by hydroxide ions to release oxygen gas, water molecules, and 4 moles of electrons. So you write like this. Anode, OH negative aqueous, O2 gas, plus 2H2O liquid, plus 4 moles of electrons. 4. So these are the bubbles of O2 gas. Again, it is due to higher concentration of hydroxide ions as compared to chloride ions. Recall gain of electron or electrons is reduction and loss of electrons is oxidation. So reduction takes place at cathode and oxidation takes place at anode. Notice one thing here that is you need to write AQ instead of L, which means aqueous. AQ means aqueous or in water. The ions are in water. Concentrated sodium chloride, NaCl. Now, what about concentrated sodium chloride? You know that hydrogen gas is produced at cathode and chlorine gas at anode. So these are hydrogen gas. This is Cl2 gas. So cathode reaction will be like this. 2 H positive ions plus 2 electrons, H2 gas, anode, 2 Cl negative aqueous gives Cl2 gas plus 2 electrons. We'll get yellow bubbles of chlorine gas and colorless and explosive bubbles of colorless and explosive gas, that is hydrogen at cathode. Aqueous copper 2 chloride. You know that metals below hydrogen get discharged due to the reason that they have high ease of discharge and low difficulty of discharge as compared to hydrogen ions. So here we will get copper ions gaining electrons at cathode like this. These are copper metal. This one is copper metal and this one is chlorine gas. So at cathode, we have Cu plus 2 aqueous plus 2 electrons, we get Cu solid. The temperature is not high in the solution, it will produce as Cu solid. At anode, chlorine gas is released only if the concentration of chloride ions are high in the solution. So I will write the loss of electrons by chlorine here. Cl negative aqueous, 2 moles of chloride ions, we get Cl2 gas plus 2 electrons. Aqueous copper 2 sulfate with copper electrodes. Now, what if we have copper electrodes instead of graphite or carbon electrodes? These are copper electrodes. At cathode, there will be reduction or gain of electrons by copper ions, and you can write reverse form of this reaction at anode. That is, product become reactant and reactant become product. Like this, I'm going to write it at cathode, the gain of electron by copper 2 plus ions, Cu plus 2 aqueous, 2 electrons, you will get Cu solid. The reverse reaction of this one will be, reverse form will be written at anode, that is Cu solid dissolved to produce Cu plus 2 ions. The reason is that copper electrodes are active and they will participate chemically in the electrolysis. And in order to compensate the loss of Cu plus 2 ions in the solution, copper anode dissolves. This is copper anode dissolves. And there's a increase in mass of cathode. Increase in mass. Cathode. Remember, at cathode there is reduction and at anode there is oxidation. State that metal objects are electroplated to improve their appearance and resistance to corrosion. Electroplating is the process of depositing a layer of desired metal on any other metal, like you can electroplate iron car parts, iron utensils, etc. You know the meaning of electro, that is current, and plating means that act of covering a metal object with a thin layer or coating of a different metal. Why metal objects are electroplated? To improve appearance and resistance to corrosion. To improve appearance and resistance to corrosion. Electrolysis can be used to refine metals. Electrolysis can be used to refine metals. For example, if we have a sample of impure copper that we want to refine, we set up a unique electrolysis cell to do that. The cathode will be made of pure copper. It will be made of pure copper. The anode will be made of impure copper sample. Impure copper sample. The electrolyte will be a solution of a copper salt. Like best, you can have copper 2 sulfate or nitrate. This is electrolyte. The process in which a metal which is likely to corrode is coated with a thin protective coating of a metal. For example, galvanizing of iron, galvanizing of iron, like coating with a layer of zinc, coating with a layer of zinc. Object to be plated is made cathode and the metal we wish to plate is made anode. Electroplating is carried out to enhance metal appearance. To enhance metal appearance, metal, or you can even say objects appearance. Like to utensils, crockery, prevent corrosion of the metal. It prevent corrosion of the metal. The idea of the electroplating cell is very similar to that of refining. Now I'm going to explain you through label diagram how are you going to solve this past paper question. Question says, I'm writing the question. Draw a labeled diagram to show how a fork made of nickel is electroplated with silver. You must show in your label diagram workable arrangements with two electrodes dipping in liquid. Two electrodes dipping in liquid connected to power supply, connected to battery or power supply with two wires and no obvious gaps. Nickel or the fork is negative electrode. Nickel or fork is negative electrode, which is cathode. And silver is positive electrodes. Silver is positive electrode. Electrolyte is labeled soluble silver salt or electrolyte. Soluble silver salt, like silver nitrate or silver sulfate. The diagram would be like this. This one will be silver electrode. Short fat line represents cathode. This is the fork. This is silver. Power supply or battery. We have electrolyte. AgNO3 or Ag2 SO4. The cathode is made up of nickel fork and anode will be of silver. You must have a salt, preferably nitrate or sulfate of silver as an electrolyte. Battery as the source of current in this. Thanks for watching. Press like, give comments and share my video. For more videos, subscribe my channel and press the bell icon.